Deep in the British Museum lies a pair of broken clay tablets from 700 BC. This is the Mul Apin, a Babylonian star manual that tracks 71 different stars and constellations, including one they literally just called the Hired Man. And what makes these tablets extraordinary isn't just their age. It's that they contain the mathematical logic, the observational framework, and the celestial architecture that would eventually become the foundation of Western astrology and astronomy as we know it. These Mul Apin clay tablets represent the most widely copied astronomical text in all of ancient Mesopotamia. Scholars Hermann Hunger and John Steele called it, and I quote, "the most important work of Babylonian astronomy," and yet most people have never heard of it. So let's decode it. The name Mul Apin translates to the plow star, taken from the very first words inscribed on the opening tablet. This was standard practice in Mesopotamia. You named a text by its first line, the way we might name a papal encyclical today. That first constellation, the plow, was long identified with the stars of Cassiopeia, Andromeda, and Triangulum. But recent research using digital planetarium software has narrowed that identification down to Cassiopeia alone. Specifically, the 5 bright stars Alpha through Epsilon that form that distinctive W shape you can spot even in twilight. Now, here's where the timeline gets fascinating. The earliest surviving copy of Mul Apin was made in 686 BCE, but the text itself is far older. Most scholars believe it was originally composed between 1200 and 1000 BCE, and the astronomical observations it records are older still. Astrophysicist Bradley Schaefer computed that the heliacal rising dates recorded in the tablets fit the latitude of the ancient city of Assur at around 1370 BCE, give or take a century. That means some of the data in these tablets was already 300 years old by the time someone first compiled it into a unified document. Think about that. Generations of Babylonian skywatchers standing on temple rooftops night after night, tracking when stars first appeared on the horizon at dawn. And their observations were so precise that modern astronomers can reverse engineer the exact location and century from which they were watching. The heart of Mul Apin is its division of the entire sky into 3 great bands, called the Paths of the Gods. The Path of Enlil covered the northern sky with 33 stars and constellations. The Path of Anu spanned the equatorial zone with 23 entries, and the Path of Ea took in the southern regions with 15. That gives us 71 celestial objects cataloged in total, of which 31 received explicit Akkadian names alongside their older Sumerian terms. These weren't arbitrary divisions. The boundaries fell at roughly plus and minus 17 degrees of declination. Through these 3 bands serpentined what the Babylonians called the Sharanu, the path of the moon, which was also the path of the planets. This is the zodiac, or rather this is the protozodiac, because Mul Apin didn't recognize 12 constellations along that path. It recognized 18 constellations in the moon's path. The Babylonians would later pare this down to 12, each occupying 30 degrees of arc, creating the standardized zodiac that the Greeks adopted and that horoscope columns still use today. But in Mul Apin, we see the earlier, messier, more organic version. And remarkably, the 18 constellation system wasn't simply replaced. Astronomical diaries from Mesopotamia show that both systems were used in parallel right up until the end of cuneiform civilization. The tablets didn't just catalog stars, they tracked time. Mul Apin operates on an ideal 360-day year, a beautifully round number that made calculations elegant but didn't quite match reality. The actual Babylonian calendar used 12 lunar months totaling about 354 days, more than 10 days short of a full solar year. To fix this drift, they intercalated an extra month roughly every 3 years. Mul Apin contains 2 different intercalation schemes for determining when to add that month. And here's the thing. Scholars have demonstrated that these 2 schemes don't actually agree with each other. Whether this represents competing traditions stitched together, or deliberate alternatives for different purposes remains debated. The tablets also contain something remarkably practical, a shadow measurement scheme. Using a gnomon, a simple vertical stick 1 cubit tall, Babylonian astronomers tracked how shadow lengths changed throughout the day and across seasons. At the summer solstice, noon shadow measurements were shortest. At the winter solstice, longest. The ratio they used for shortest day to longest day was 1:2, which is a reasonable approximation for Babylon's latitude. This wasn't abstract theorizing. This was ancient astronomy as engineering, as agriculture, as statecraft. And then there are the constellations themselves, which is where things get truly bizarre by modern standards. Take Pabilsag, the figure we now call Sagittarius. The Greeks turned him into a noble centaur, the wise Chiron, tutor of heroes. But the original Babylonian version? Pabilsag was depicted as a winged, dog-headed, scorpion-tailed composite creature who served as a psychopomp, a guide for the dead along the celestial road. Wings, dog head, scorpion tail, all stripped away by Greek rationalism in favor of a horse body and a dignified human torso. And here's a coincidence that has fascinated stargazers for centuries. Pabilsag's arrow points directly toward the densest part of the Milky Way, toward the galactic center. The Babylonians didn't know what a galaxy was, but they recognized that region as unusually bright and rich with stars. Modern astronomers have confirmed the galactic center lies at about 27 degrees Sagittarius. The ancient archer across 3 millennia still aims true. Or consider Capricornus, the sea goat. Where on earth does a goatfish come from? The answer traces back to the Sumerian god Ea, whose sacred boat had a goat's head carved on the bow. Over centuries, that goat boat morphed into a goatfish hybrid, and then that hybrid got projected onto the stars as a constellation. Cultural evolution fossilized in the night sky. The Babylonians also wove their theology directly into their astronomy. Jupiter belonged to Marduk, king of the gods. Venus was Ishtar, goddess of love and war. Saturn answered to Ninurta, Mercury to Nabu, Mars to Nergal, the sun to Shamash, the moon to Sin. When you tracked a planet's movement, you were tracking a deity's intentions. This is why ancient astronomy and divination were inseparable in Mesopotamia. The sky wasn't just a clock, it was a message board from the gods. Around 400 BCE, this entire system traveled west. Eudoxus of Cnidus and other Greek astronomers adopted Babylonian constellation frameworks, mathematical models, and observational methods. The transmission reshaped Mediterranean science permanently. Mul Apin was copied and recopied for over 700 years, from the Neo-Assyrian period through the Seleucid era, with the latest known copies dating to around 300 BCE. Across all those centuries and all those copies, the text remained, in the words of John Steele, remarkably stable, with only about 200 minor spelling variations across every surviving exemplar. That kind of textual fidelity tells you something about how seriously Babylonian scribes took this document. Tablets have been excavated at Nippur, now held at the Penn Museum in Philadelphia, and at Nineveh, housed in the British Museum in London. As recently as the last few years, scholars including Enrique Jimenez and Irving Finkel have published newly identified Neo-Assyrian fragments and made joins to previously isolated late Babylonian pieces. These broken clay tablets, 3,000 years old, still yielding new information, still being decoded, still reshaping our understanding of where our own systems of timekeeping, constellation mapping, and celestial observation actually began. Not in Athens, not in Alexandria, but in the mud brick cities of Mesopotamia, where someone pressed a reed stylus into wet clay and wrote down the stars.